Okay, I'm sorry about the background noise, but my AC is not working worth a shit. It's like 80 degrees in here and I have to have those fans running. I finally got my 3D printing project done. It didn't work quite as well as I hoped. This is actually my second prototype. The first one was a little bit too small, so I had to heat this part in order to insert a pipe into here. So I made it slightly larger, but it's too big. So I put some super glue on the inside of this cuff, and then I put some silicone around the outside of it. So this pipe is like mounted in here permanently, but we finally have the central vac set up with two 8.4 inch motors, 112, 175 motors, and they're running in parallel. We've tested it. We've tested the Canavac with a single motor. We've done a kind of an impromptu and not, you know, I didn't have the hose straightened out for the series motor test, so we still saw some differences in it, but probably not quite as accurate as it could have been. But we're gonna go ahead and straighten the hose out here. So I've got them both connected to different power sources, or different circuits rather. I'm just gonna take electrical measurements from one of the motors, just from the motor can here, because that one's closer to me. Once I had switched this on, the other one wouldn't shut off, so I guess maybe I hadn't done the wiring quite right with the low voltage system. It's like I can turn them both on, but it doesn't want to shut off. So let's do this again. We have our ambient voltage. We're gonna turn this on. Induced voltage. Okay, I tried this both ways. Maybe I misunderstood what he told me, but I have the low voltage system attached. So like the wires go out, they come in from this piece and then they go out to both of them, but apparently that doesn't work. Because it's like once one of these starts running, both of them won't shut off. Okay, well, I'm gonna have to come up with a backup plan. All right, so we're putting this one back on its own switch with this, and we're just gonna have to manually activate it until I get to the hose tests. Because like I said, once I turn one of them on, they will not shut off when they're wired together. So, okay, let's take our airflow measurement from the hose port here. I imagine, just like the beam, we're probably going to have to take that in a unit other than feet per minute. Let's take that in meters per second here, because it is going to go over the 4-digit limit. So let's switch them both on. All right, we got them tethered back together. I've got the hose. I tried to avoid too many, heavy curvatures to it, but I can't really lay a 30-foot hose fully straight, so we're just gonna have to deal with this. I know I didn't have the hose straightened when I did it with the single motor test. We still had a few curves to that, although that had to make a full 180. I suppose this makes a 182, but just not quite as tight. So yeah, let's see what parallel unit can do. I just went and checked, both of them are running. Ah. And like I said, they don't shut off when they're wired together. Okay, so there we have it. It's like we've tested this unit with a single 8.4 inch motor. We've tested it in series. We've tested it in parallel. It's like, I know there are some stronger motors out there than mine, but they're not too significantly stronger. So I feel like this is probably about the peak central vacuum performance. And I think I'm going to do kind of a recap at the end of this video so we can see what the specs in each of these configurations were like. Parallel motor mounts like this specialize in airflow, but the suction of them is marginally affected, as to where when they're in series it's the complete opposite. The suction goes up. Here you have two motors which are equal in power, so they're each pulling in that same amount of airflow, but they can create more suction power by being in series. As to where, you know, when they're in parallel, the suction is only going to be as strong as a single motor, because, I mean, if one motor is stronger than the other, air will always follow the point of least resistance, and if there is less resistance, you know, going through one of the motors rather than, you know, through the cleaning port, it's like it will pull air in through that other motor. So it's important that they're balanced.